So to ascertain whether or not this is a series that converges, I certainly need to find out what the nth term looks like. But wouldn't you agree these numbers are kind of looking familiar? So I think that 24 can be interpreted as 2 times 3 times 4. So it's 4 factorial. When you multiply it by 5, you get this. When you multiply that by 6, you get that. When you multiply that by 7, you get that. So I certainly have a factorial downstairs. But I don't think it's going to be this. Because technically speaking, when I plug 1 in for n, I should get this first term, and its denominator really is 4 factorial. But I get that 4 factorial when n is equal to 1. So what's being factorial here is a 4, but that's 3 more than my position in the expansion of the series. So don't you agree that really should be an n plus 3 factorial? You can check me if you think I made a mistake. Plug in 1 in for n, you get 4 factorial, there it is. Plug 2 in for n, you get 5 factorial, there it is, etc. Now, as far as my numerator is concerned, certainly in absolute values, I'm increasing by a factor of 2 each and every time. So it looks like my numerator is exponential, maybe like a 2 to the n. But that's not going to work, because actually, when I plug 1 in for n, my first numerator should be 2. It's an 8. So shouldn't I actually increase the n by, well, jeepers, let's figure it out. What power of 2 must I raise? Did I say it correctly? What power should I raise 2 to get 8? Should be 3. But 3 is 2 more than that position. And so I'll replace my n with an n plus 2. Here too, double check these for make sure it checks out. Looks like I got a sign change in every term. So let me put something like that in, I think. Let me check it. When n is equal to 1, this is negative, but the first term is positive. So I made a mistake. It's an easy fix. I'll just add 1 to the n. Or shall I say add any odd integer to n, like n plus 3, n minus 7. Doesn't make any difference. It'll give you a first term that's positive. So now that I've rewritten the nth term explicitly, I will use a ratio test to determine whether or not I converge. Here is the n plus first term in absolute values. Here's the reciprocal of the nth term. Of course, massaging a tad bit. I'm seeing cancellation all over the place. I think within the limits, this is all I'm left with. But that is equal to 0, which is strictly less than 1. Therefore, our series converges. Converges because it converges absolutely by the ratio test. Again, I can clarify that more easily by saying I converge absolutely by the ratio test, therefore I converge. I should have added that in. Is it